In this video, we are going to proceed with the next topic outline, which is independence test. So independence tests are used to assess whether two factors are independent or not. So before this, we only involve the table only involve or the problem that we use only involve one factor. But for this case, for this problem, we will involve two factors or two categorical variables. So to test the independence of these two categorical variables, we can use the independence test, or we can also call it as chi-square test of independence. So the chi-square test of independence evaluates the relationship between two variables. Okay, it is a non-parametric test performed on categorical. It can be nominal or ordinal data. So first of all, to define the null and alternative hypothesis for the independence test of two variables, okay, we can denote our H node or null hypothesis as two categorical variables are independent. And for the alternative hypothesis, it will be two categorical variables are dependent. Or we can also write it as there is no relationship between the two categorical variables for the null hypothesis. And then for the alternative hypothesis, it will be there is a relationship between the two categorical variables. Okay, so these are our assumptions for the hypothesis. Okay, so once we gathered our data, we summarize the data into the contingency table. So the data for the two variables, normally we place it in the contingency table. So one variable is called as the row variable and the other variable is called the column variable. And we call the table as R times C, where R is the number of rows and C is the number of columns. Okay, so remember that rows go across or horizontally and columns go up and down or vertically. So for example, we have this 2 times 3 contingency table which look like this. Okay, so here we have two rows, the first row and this is the second row. And this one is the column. Remember, column goes up and two down, okay, or vertically. This is the first column, second column, and third column. So each value in the table here, we call it as cell value. Okay, for example, for the cell value C23 means that it is in the second row and third column. So it's same like matrix. Okay, so the row 1 sum is the addition or the summation of C11 plus C12 plus C13. So here we can add all the cell value in the first row. So this is the row 1 sum. And the second row here is the row 2 sum, which we will add the cell value in row 2. So C21 plus C22 plus C23. And then for the column 1 sum, it will be C11 plus C21. And for the second column sum, it will be C12 plus C22. And the last one is the column 3 sum, which is C13 plus C23. So the total of this cell value should be the same, okay? Which means that the summation of row 1 and row 2 should be equals to the summation of column 1, column 2, and column 3 sum. So that will be the total of our sample. Okay, now the important part is the expected values. which are computed from the observed value, and they are based on the assumption that the two variables are independent. So for the independence test, the formula for computing the expected values for each cell would be equal to the row sum times with the column sum divided by the grand total. Okay, so we can get the value of the expected value. Okay, now the degree of freedom for the chi-square test of independence are based on the size of the contingency table. So the formula for the degree of freedom is the number of row minus with 1 times with the number of column minus 1. So for example, we have a 2 by 3 table. So the degree of freedom would be 2 minus 1, which is number of row, which is 2, and the number of column, which is 3 minus 1. So it will be equals to 1 minus 2. So the degree of freedom is equals to 2. So the degree of freedom is important because we want to find the critical value, okay, the chi-square, alpha, and degree of freedom.